I see this statement as absolutely true. K-means works by assigning each data point, in this case, each customer, to the closest cluster centroid. It's a one-to-one relationship. You won't find a customer belonging to multiple clusters. It's like sorting socks into drawers. Each sock goes into only one drawer. This is the core goal of K-means. The algorithm iteratively tries to find the arrangement of clusters that makes the total sum of squared distances from each point to its cluster center as small as possible. Imagine it like arranging furniture in a room. You want to put everything as close to its designated place as possible. This is what K-means aims to achieve for your data points and the clusters. I'm gonna say, this is false. While it might initially improve the silhouette score, it's definitely not guaranteed. The silhouette score measures how similar a point is to its own cluster compared to other clusters. If you increase clusters too much, you'll just end up with lots of tiny, poorly defined clusters, leading to a lower silhouette score. It's like dividing your socks into too many drawers. It gets messy and doesn't make things more organized. This statement is false. The centroid is the average of all the data points within a cluster. It is generally not one of the original data points itself. Think of it as the center of gravity of each cluster. It's a calculated value, not necessarily an actual data point. I'm using K-means, a popular machine learning algorithm from the Sklearn library, to group similar things together. It's like sorting your socks. K-means finds groups, clusters, of similar items based on their characteristics. This is a multiple-choice question testing your understanding of how K-means works and what it tells us about the data. I've used K-means to split my customers into 3 groups based on what they buy. Now, let's see if you understand what those groups mean. This statement is true. K-means always puts each customer in only one group. This one is false. The centroids, which represent the centers of each group, are usually averages of the data, not necessarily a specific customer. Yep, this is true. K-means tries really hard to make sure the distances between customers and the centers of their groups are as small as possible. False. Adding more groups doesn't automatically improve the results. Think of it like cutting a pie. Too many slices can make it messy. I start by randomly placing the centroids, or center points, of my 3 clusters. Think of it like throwing 3 darts onto a map of your customer data. These darts represent the initial guesses for the location of the cluster centers. Next, I assign each customer to the closest centroid. This means I measure the distance of each customer to each of the 3 centroids and assign the customer to the cluster with the closest centroid. It is like assigning each point on the map to the closest dart. Now, I recalculate the position of the centroids. I find the average location of all customers within each cluster and place the centroids there. Imagine the darts moving to the center of all the points assigned to them. I repeat the previous 2 steps, assigning points and recalculating centroids, until the centroids no longer significantly move. This means the clusters are stable. It is like the darts settling to their final positions on the map. This is how K-means finds the best cluster arrangement. I'm using a popular machine learning library, Sklearn, to perform K-means clustering. K-means is an algorithm that groups similar data points together into clusters. This is true, since each customer can only belong to a single group in K-means. It's like choosing your favorite ice cream flavor. You can't pick more than one at a time. This is the goal of the K-means algorithm. I want the points within each cluster to be close together, and the clusters to be far apart. This is like arranging furniture in a room. You want similar items grouped together, keeping them as close as possible to minimize the space they occupy. This statement is false. The centroids are calculated as the average of the data points in a cluster. They are not necessarily one of the original data points. This is like calculating the average height of a group of people. The average height doesn't have to be the height of anyone in the group. This is false. While increasing the number of clusters might initially improve the silhouette score, it can lead to overfitting if there are too many clusters. It's like dividing a cake into too many slices. Each slice might be smaller and less appealing. I think of K-means like a really good sorting machine. It takes each customer and assigns them to only one group based on how similar their purchases are to other customers in the group. So, this statement is true. Let's imagine each cluster is a group of friends with similar tastes. The centroid is like the average friend representing the entire group. It's a calculated point, not necessarily one of the actual friends' data points themselves. Thus, the statement is false. K-means really wants to keep things as close together as possible. It tries to minimize the total distance, squared, for mathematical reasons, of each customer to the average customer in their assigned group. This is what it optimizes. It makes the groups as tight as possible. Therefore, the statement is true. Think of this like dividing a pizza. If you only have 2 slices, they might be very different from each other. But as you cut it into more slices, they're more similar within each slice. However, at some point, you're cutting it into unnecessarily tiny pieces. That's overfitting. The silhouette score measures just this balance. Adding too many clusters doesn't guarantee improvement. It can even make things worse. So this statement is false. I see this statement as true. The K-means algorithm works by assigning each data point, in this case each customer, to the nearest cluster centroid. Each customer can only belong to one cluster at a time. This statement is false. The centroids are calculated as the average of all the data points within a cluster. They're not necessarily one of the original data points themselves. Think of it like calculating the average height of a class. It's unlikely to exactly match anyone's height in the class. This is true. K-means aims to find the best cluster arrangement to minimize the sum of the squared distances. It tries to make the clusters as compact as possible. False. While increasing the number of clusters might improve things initially, it can also lead to overfitting. Imagine splitting a dataset into lots of tiny clusters. That might seem good, but it's actually capturing noise, not real patterns. The silhouette score measures the balance between clustering quality and noise, and increasing clusters beyond a certain point might decrease the overall score. Think about this statement as a core principle of K-means. K-means works by assigning each data point, in this case, each customer, to the cluster with the nearest center, called a centroid. You can't split a single customer, they must belong to only one cluster. So, this statement is true. This statement describes K-means' main goal. The algorithm iteratively moves the centroids to minimize the overall sum of squared distances between each data point and its assigned centroid. It's like finding the perfect arrangement to minimize how spread out everything is from their cluster centers. Therefore, the statement is true. This one is tricky. K-means calculates centroids as the average of all the data points within a cluster. It's unlikely this average will match any single original data point perfectly. So this statement is false. Here's where things get interesting. Increasing the number of clusters can improve your silhouette score, a metric for how well separated clusters are. But only up to a point. Too many clusters lead to overfitting. You end up with clusters that are too specific, losing the bigger picture. So, this statement is false. This question tests your understanding of the K-means clustering algorithm. We'll explore how K-means groups data and what properties its clusters have. This statement is true. K-means works by assigning each data point, customer, to the nearest cluster center, centroid. You can't split a customer, they belong to only one cluster. This statement is false. The centroid is the average of all the data points within a cluster. It's unlikely to be one of the original data points, unless, by chance, the average coordinates happen to exactly match a data point. This is true. K-means minimizes the sum of the squared distances from each data point to its assigned cluster's centroid. That's the core goal of the algorithm, to make clusters as compact as possible. This is false. While increasing the number of clusters can sometimes improve the silhouette score, it's not guaranteed. At some point, adding more clusters just fits the noise in your data, leading to worse performance. The instructions tell you to choose every answer that is correct based on your understanding of the K-means algorithm. This clarifies that you are answering a multiple-choice question.